Welcome to this tutorial on how to use the application MCCrystal. I am Ana Luisa Pinto Queiroz, chemical engineer, PhD candidate in pharmaceutical technology, and the developer of this application. MCCrystal was designed to use Raman spectral data to determine the percentage crystallinity index of microcrystalline cellulose by partial least squares regression and by an univariate model of the ratio between the peaks at 380 and 1096. MCCrystal also performs spectral baseline correction by linear interpolation, spectral normalization by Standard Normal Variate, SNV, and principal component analysis. The focus of this video will be on how to use this application, but detailed information about all these models is available in the manuscript in the Resources tab. To get started, we need to organize our data in a format that MCCrystal understands. This is the most critical part of the usage of this application. There are 5 requisites that must be met. I am going to open a sample raw data file, so it's easier to visualize what I am going to say. The rule number 1 is that the first line of the file should contain the Raman shifts, and the first column should contain the name of each spectrum, as you can see here in this example. The rule number 2 is that the Raman shifts should range from 1500 to 200. Checking our example file, we can see that the cell B1 contains 1500, and if we go to the last cell of this line, we see the value is 200. So this confirms that our sample data is ranging from 1500 to 200 in Raman shift. The rule number 3 is that the data must not have missing values. The only cell that can be empty or that can contain a numeric or a text input is the cell A1. That's because this cell is not being used by the application. The rule number 4 is that the Raman intensities must be in a numeric format. In Excel, we can click in this square here in the top left corner and go to this section called Number and choose from the options the option Number. This will ensure that all our values in this Excel file is a numeric value. The rule number 5 is that the file has to be saved as a comma-separated values file, known as .csv file. In Excel, that can be easily done by clicking File, Save As, and choosing from the options here, comma delimited. I'm not going to save this because the file is already saved in this format. Those are the 5 rules that the raw data must obey. There is a raw data sample in the Resources tab to help you to create your own dataset following those instructions. This is the file there, and this actually is the same file that I am going to use in this tutorial. If your aim is to perform the spectral treatment by baseline and normalization, or to determine the percentage crystallinity index, don't worry. There isn't a minimum number of spectra that can be uploaded. If you only have one spectrum, the spectral treatment and the percentage crystallinity index will be calculated accurately. However, for a principal component analysis, you might want to use as many spectra as you have available. The maximum number of spectra is only limited by the size of the file, which in this case is 30 megabytes. This is a massive size of file in the format that we are using, so I'm sure that this will be enough even if you have many spectra to be analyzed. Just bear in mind that several calculations are being performed in the background. So if you're using 1,000 spectra, this will take longer than if you're using 100 spectra. Having said that, we can move to the best part. Let's use the application. First, we need to flag which type of probe was used to acquire the spectra. The model of this application was built using data from a fat probe and also data from an immersion probe or MR probe. So those are the two options that we can see in the application. I will leave fat probe selected there because this was the raw data that I chose to work with in this tutorial. So I am going to open. And the good news is that MCCrystal will automatically do all the analysis. That's the only step that you need to do. So just browse for your raw data and open it, and as soon as you upload the file, all the calculations will be done. Now let's understand the results. The first result is a table containing the percentage crystallinity index determined by two models. An univariate model, which is the function of the ratio between the peaks at 380 and 1096, and the percentage crystallinity index determined by partial least squares regression. You can choose any of them, just be consistent. So do not compare the percentage crystallinity index, for example, of batch 1 determined by this method with the percentage crystallinity index of batch 5 calculated using the PLS method. So just be consistent. If you choose one of them, so use it throughout your analysis. And the last two columns are the values of principal component 1 scores from the principal component analysis and the principal component 2 scores as well. You can download those results by clicking in this link, and the file will be an excel.csv file. The second set of results shows the spectral treatment. The spectra are baselined and normalized by SNV. If your spectra are already treated, don't worry. This will not cause any error or any difference in the analysis. We can see here we have two graphics, and the graphic in the bottom is the raw spectra plotted. And here we can see that we have baseline shifts and some fluorescence, which is characteristic of microcrystalline cellulose. And on the processed spectra, we can see that the Raman fingerprint of MCC is much more clear. You can also download the treated spectra by clicking this link, and again you receive a Excel file, .csv file. And another function of this tab is that we can average the spectra that we are seeing here in this plot. I know that I have 60 spectra in this file, so let's say that I actually have only 2 samples and I took 30 spectra of each sample. So I will say that my replicates are 30. And here I have the spectra of my 2 samples, which each one of them is the average of 30 spectra. And that can be done for any number, since it makes sense. For example, if I want to say 40, that doesn't really make sense, because what the program is doing is averaging every 40 lines, and I know that I only have 60. So it is averaging the first 40 and assigning to the first sample, and then trying to average the next 40, but I would have just 20 to be averaged there. So here, one thing to be considering is that the number of replicates to be averaged is the number of lines in sequence. So when I say 2 replicates, this is being averaged every 2 lines of your raw data. I will leave as 1 because I know from this data that we don't have replicates. And now let's move to the principal component analysis results. Here we have a score plot which shows the geometric location of each sample due to similarities or differences among them. Samples that are close to each other are similar, and samples that are far from each other are different. And that's very helpful to identify spectra that are outliers or samples that are out of control. For example, the default display is PC1 against PC2, but this can be changed. So if you type here any number, it will automatically update the graphic. So in this case, we have 1 and 3, so we have PC1 plotted against PC3. Note as well that the percentage explained variance is being displayed in the label just beside the number of the principal component. So for the third principal component, 4.6% of the variance is being explained, while for PC1, 51.2% is being explained. I will leave this as the standard 1 against 2. If you want to see as a graphic the explained variance for the first 4 principal components, you can just check out this graphic in the bottom right corner. And here we have for the first 4 principal components what is the explained variance. This is displaying just for the first 4 because for a Raman spectral principal component analysis for MCC, we don't really want to model more than 4 principal components because we would end up modeling noise. But if you really want to know what is the explained variance for any other principal component, you can only type it here. So for the principal component 7 will be displayed together with the name of the principal component in the axis that you choose. So for here, for PC7, the explained variance is 1.7, and that would work for any number. And you see that the value is is decreasing more and more. In the same tab, we have here a scores plot of the first principal component against the number of sample. So this, for each spectrum, we have the value of the first principal component score. This can be used as a control chart graphic. And in the bottom left, we have the correlation loadings. And this is for each principal component, and you can change here for the principal component that you want to analyze. I will leave as 1 as well. And these correlation loadings explains why the samples were placed in the geometric locations in relation to that component. Again, more information about those models is available in the Resources tab. The partialist squares regression tab has an informative data about the model that was used to calibrate the analysis. So here, note that the probe type selected is the fat probe, and here it's also written fat probe. And if I change here to EMA probe, this will be changing the and all the values here as well. This is just the information on the calibration model. won't change when you change your raw data. And finally, the last tab has just a displacement of the raw data that was input, and also it counts for you how many lines and how many columns were input, and you can check if those are corrected or not. So for example, here we know that our first cell containing the Raman shifts was starting from 1500, and we can see that the first column contained the name of each spectrum. This is just the heading of the raw data, because spectral data is very large, so the application would be a little bit slow, so we have just the headings there, but it's enough for us to check if everything was imported correctly. That's all for today. Please let me know if you have any query. You can contact us in the contact tab. Otherwise, you can search for the resources that we uploaded here. Will be a publication available, and there are some options for troubleshooting as well. Thank you.